Have you ever seen those games where you press a button and it makes you dash for a few seconds? Take this game for example. You press Q and you dash and there's a cooldown. It's pretty cool. So today I'm going to be teaching you how you can script your own anime dashing system. We're going to start really simply learning how to push objects in Roblox, because when you're dashing you're basically being pushed. And then we're going to learn how to apply that push for a few seconds, because that's what a dash is. It's like a ghost behind you is pushing you for a few seconds and then letting go. And some games actually have some sort of agility system, where if the player's agility is higher, then they'll sprint a longer distance. I'll help you do a mini version of that as well in this value-packed video. Let's get started. First, let's figure out how you can move an object in Roblox, because sprinting is literally just moving an object. Let's say that you have a part in Workspace and you want to move this part. Now there's a whole bunch of ways to move an object, but in our case we're going to be applying a force. And in Roblox this is called a vector force. You can think of a force as basically something that pushes or pulls you. So if this is me and we apply a force to the right, then I'll get pushed to the right. And if we apply a force to the left, then I'll get pushed to the left. And if we apply a force in the direction that I'm looking, then I'll get pushed in that direction. And that's literally how dashing systems work. We just apply a force in the direction that the player is looking. So let's take this into Roblox. So this is my character. Please take a moment to appreciate my fake dominus. Okay, so we're trying to push this character. This is me. And the way we're going to do this is we're going to add a vector force. So right inside of my humanoid root part, I'm going to right click, insert object, vector force. And now, whoops. Okay, I guess that's gone. Okay, so here's the vector force, and this thing is basically going to move me. So I'm just going to click on visible to make it visible, and you'll realize that there's nothing happening right now because we're missing a few things. So the first thing is that we need an attachment 0. So this is basically where the force is going to get applied to. So I'm going to set this to the root rig attachment, and as you can see, my character is already being shoved. And you can actually see the arrow right there. This is the force itself. This is pointing in the direction of the force. Now let's look at this force for a second. Let's look at these three numbers right here. So the first number is 1,000. This means that it's going to push me with 1,000 units in the X direction, which is this way right here. So it's pushing me 1,000 units in the direction that this arrow is facing. Now what happens if I take this 1,000 and then flip it? So what if instead of 1,000 I turn this into negative 1,000? Well, now look at that. Now I'm being pushed in the opposite direction. And what if instead of this first number being the negative 1,000, what if I set this middle number to 1,000? Well, as you can see, the force is being pushed upward, but I'm not actually moving. And that's because there's actually gravity pushing downward. And if I want to be like a heavenly angel, then all I have to do is increase this number right here. So this is the amount of force that's being pushed in the Y direction, which is up and down. And if I just multiply this by 10, so if I add a 0 right here, boom. And yeah, I'm in heaven now. And I've gotten rid of my force by setting it to 0, and now I should be falling. Let's see how long this takes. Okay, it's taking too long. Okay, so the main observation here is that if I take this number and I increase it, so if I make this bigger, then I'm going to get pushed harder. And as you can see, I'm actually getting pushed harder that Roblox thinks my character is now walking. And let me try changing this to 5. And now my character is walking a little bit faster. Okay, what if I change it to 8? Uh-oh, he's pacing. He's speed walking. He's late to class. This is you on your way to pressing subscribe. Seriously. Okay, so why don't we change this 8 to something like 15? And now, yeah, that happens. And oof. They should actually use that for the oof sound. I think it's better than what we have right now. All right, so now that you know how a vector force works, let's actually add it in through a script. So add a script into server script service, and you can just call this dash server, and then you can get rid of this print hello world. All right, so let's start with detecting when a player joins the game. So let's start with detecting when a player joins the game. So this is basically just saying whenever a player has been added onto game.players, which is this thing right here. So when I click play, as you can see, my name right here just got added into game.players. So this function right here will execute. And just to make sure that it works, we're going to print player.name as joined. And as you can see, my player entered here and it said my name has joined. All right, and now we need to get their character. So we're going to use player.characterAdded. And now this thing will run after my player gets his character added. So what that means is whenever my character loads. So I'm going to print player.name character loaded. And so when I click play, it'll say my character has been loaded. Now remember that in order to push something in Roblox, you have to add a vector force. And in our case, we're going to apply it to the humanoid root part. So this is your character. This is a model in workspace with your name on it. And it has a humanoid root part. And all we're going to do is we're going to do this right here. We're going to add a vector force just like this, but we're going to use our script to do it. And the way to do this is like this. Okay, so at this point, we've basically said, all right, so the humanoid root part is going to be character, wait for child. So this basically means wait until this thing has loaded. So humanoid root part equals character, wait until the humanoid root part loads, and then that will be set to our humanoid root part, which is once again, this thing right here, So this is our character, and this is our humanoid root part, and we're using this to get it. And then this line right here is basically saying, okay, add a new vector force object into that humanoid root part, which is basically what we did earlier. So as you can see inside of the humanoid root part, there's now a vector force. And remember what we had to do, we had to set this vector force's attachment 0 onto this thing called root attachment, and that makes you move. So that's what we're going to do, vector force dot attachment 0 equals humanoid root part wait for child root attachment. So this root attachment right here is basically, and as you can see, it's working because my character is actually being pushed. And this root attachment right here is this thing right here. So humanoid root part wait for child root attachment, which is what we've done right here. So this is pretty cool. Now my character is moving. However, we need this vector force to point in the direction that our character is facing. And the way to get the direction that your character is facing is by using something called look vector. So, all right, so this right here, this basically says every 1 second, set the force of this vector force to the C-frame's look vector. And this look vector right here is basically just the direction that your character is looking at. And now you'll notice that nothing is going on here. Why is that? Well, the reason is because this look vector right here is basically a really small vector. And what I mean by that is this. So this right here is how big your look vector is. It's like really small. So imagine this as like a really weak ghost pushing you in the direction that you're facing. And we can't really expect a weak ghost to shove us really hard. So we're going to take this look vector, which is a really small push, and we're going to multiply it by, let's say, 1,000. Or let's do 100. Let's see what this does. So here I am, and am I moving? A little bit. As you can see, I'm actually moving in the direction that I'm facing, but it's really small. And for a dash, let's try making it 1,000. And now you'll see that I'm being pushed a little bit harder. Now for a dash, we don't really need this while loop. This was just to demonstrate. So I'm actually just going to take this, I'm going to put it over here. So basically, the moment that your character is added, it will basically set the force to the direction that your humanoid root part is looking. So this is the direction your character is facing multiplied by 1,000. And I'm actually going to set this to 10,000. And I'm going to use task.wait2, and then I'm going to destroy this vector force. So we have our vector force, and we've set the attachment, and then we've given it a force. So we basically told the vector force to shove me in the direction that I'm facing. And then 2 seconds later, what I'm doing is 2 seconds later, destroying that force. So this is like someone is pushing you for 2 seconds and then disappearing forever. It's like a ghost that works out but skips arm day several times a week, is pushing you, and then 2 seconds later he gets tired and then he disappears. And if we try it, as you can see, that's the dash. Now that wasn't much of a dash, so we basically have to tell our ghost to never skip arm day, and we basically just have to add a 0 here. So this is going to make him 10 times stronger. And then, bam, that's a little bit too strong. Okay, so how about this? You can skip arm day, but you can't skip it too much. So let's make this like 3. So this is going to be 30,000. So now our ghost, okay, that's still too strong. So I'm basically just going to mess with these values until I get something that I like. Okay, that's too small. Let's try 15. Okay. Now, that wasn't bad, but all I'm going to do is I'm going to set this to 0.5 instead of 2. So he's only going to push me for like 0.5 seconds, basically. And as you can see, here's the dash. So once again, a character has been added. We apply the vector force to the humanoid root part, and then we tell that force to basically face in the direction that I'm facing, and then be really strong, and then 0.5 seconds later, destroy. So this is a really great start, except now we need to basically make it so that whenever someone presses a key on their keyboard, then it will do this whole thing right here. And because now we're working with the user's keyboard, we have to use something called a local script. So inside of starter pack, insert an object and call it a local script. Alright, so this is pretty simple. So basically, line 1, we're getting the player. So since we're using a local script, we can use something called local player. So this is basically the current player. And then we're getting something called user input service. So this thing is going to help us detect whenever someone presses a key on their keyboard. And then we're using this thing called input began, which basically means whenever this player does something with user input. So basically, whenever they press a key or move their mouse or click or doing anything with input, or like, user controller or something like that. And what we're doing here is we're filtering it. So we're basically saying if that input object has a key code. So if they press something on their keyboard, and if that thing that they press on their keyboard is equal to X, so this is basically saying whenever a player presses X on their keyboard, then it will print that a player has pressed X. And also make sure that you remove this not. I'm going to explain what this is in a moment. So basically, here's our dash from before, and I'm just going to move around, and I'm going to press X on my keyboard. And as you can see, it detected that I'm pressing X. So if you were able to get this far into the tutorial, good job, let's continue. Alright, so if I'm actually chatting with someone, and what if I'm like, hi, I am a clever, and then I type F-O-X, and I'm just spamming X here, and as you can see, it's actually not increasing how many times I've pressed X. And this is because we don't want the player to accidentally sprint whenever they type X in the chat. And the way that we handle this is by doing this if statement right here. So this right here, GPE, it's called game processed event. What we're saying is if this is an event that fired when the game processed, so this basically means if the player accidentally pressed X when they were chatting or doing something like that, then return, which means don't do anything. So if they accidentally pressed X, then don't do anything. So that's all that's saying. And make sure you have this, otherwise people will randomly start sprinting whenever they're chatting. It would be funny though. Alright, so now we've detected when the player has pressed X, and all that's left to be done is initiate this whole sprinting thing. And now what we're going to do is we're going to take this dashing system, we're just going to throw it into the local script and see what happens. So the first thing we need to do is we need to get the humanoid root part. So as you can see over here, we were able to detect when the player's character has been loaded, and then fetch the humanoid root part right from there. But in our local script, we can just do something like this. So because we're in a local script, we can do some cool things like local player, and a player's character. To access that, you can just do player.character instead of doing all of this stuff here. And to get the humanoid root part, it's basically the same thing. Character, wait until the humanoid root part loads. And now all we have to do is take this vector force stuff. I'm going to press Control X, and then I'm going to go over here and press Control V, and that's basically going to copy it and put it inside of my local script. So now it looks like this. And I'm actually going to get rid of dash server because I decided that I don't need it. And I'm just going to call this local script dashing. I am the dasher. Alright, so now let's play, and when I press X, it makes me dash. So that's pretty cool. So now I'm going to look this way. I'm going to press X and whoa, that was not supposed to happen. Look at that. Why is it making me do that? I want the dash to go wherever I'm facing, and that's not what's happening right now. Alright, so the reason that happened is because of something called world space and relative space. So I'm not going to go too deep into that, but basically what we're going to do is we're just going to set the force of this vector force to vector3.new 00 negative 15,000. And what this basically does is this vector force, because we set the attachment to this thing, it's already keeping track of where our character is facing. And so we don't have to manually tell it to look at the look vector. We can just say, okay, well, you already know where I'm facing, so why don't you just go 15,000 units in front? And you're going to want to make this a negative 15,000, because if you make it 15,000, then your player will basically go backward. It's like backdash, it's like backpedaling. So just set this to negative 15,000 and it should go in the right direction. So I'm just going to jump and I'm dashing. Jump, dash. So that's already really cool. And once again, the whole reason we have to do this is because of something called relative space and world space. If you would like a tutorial on it, please let me know in the comments down below. And now is a good time to subscribe if you haven't already. Alright, so at this point, I would recommend that you tweak these values if you want your dash to be slower or faster. Right now, mine's like this, which is actually really, really fast. So maybe what I'll do is I'll set this to 12,000. Maybe I'll change this to 35. And then this should be a little bit, there we go, that's better. Now, if you're pressing X without jumping, it's gonna look a bit awkward, but if you jump and press X at the same time, then you'll have a better experience with your dash. And the whole reason for this is because when you press X, your character is actually going through some friction with the floor, and so the dash isn't able to push you as hard. And the way to fix it is by jumping, like that. So we're just going to be lazy for today, and we're basically just going to make the character jump before they dash. And the way to do this is, so inside of your character, there's a humanoid, and if you set jump to true, so see this jump right here, click this, the character will jump. It's just not working because I'm client-sided. But if I go over here, so if I go over here and I click on jump, my character will actually jump. So what that basically means is that you can't use a local script to make your character jump, because if you click jump here, nothing happens because Roblox intelligently realizes, oh, well, I don't really want the player to be able to control that. I want the server to be able to control that. So what we're going to do is we're basically going to make the server make you automatically jump and then apply this. So once again, we're going to switch roles and we're going to delegate all of this to the server. So basically what we're going to be doing now is making it so that when you press X on your keyboard, then Roblox's server, which is this thing right here, Roblox's server, it will go all the way to your humanoid, and then it will make this jump right here. It will set this to true, and that's going to make you jump. And then after you jump, we're going to immediately apply the dash, and that will basically stop any friction issues, any physics issues. And for the client and server to communicate with each other, you need something called a remote event. So that's what we're going to do. We're going to add a remote event. So under replicated storage, right click, insert object, call it remote event. And then I'm just going to call this thing communicate. And this thing's job is basically, to, and the job of this communicate thing right here is basically for the client script, the local script, to tell the server that you want this thing to be applied to your character on the server. Now, if that doesn't make sense, I'm going to have some sort of tutorial on client and server and network and all of this cool stuff right here. I'm going to have a tutorial on this sometime in 2025. So make sure that you subscribe so you don't miss out when I upload that. Alright, so now we're going to add a server script right here. And what we're going to do is we're basically going to tell this thing that when this local script calls it, so whenever this local script called dashing calls communicate, it's going to do this thing right here to the player that called it. And to do that, we're just going to go script, or we're just going to go local communicate equals game.replicatedStorage.communicate. and then communicate.onServer event connect function player. And basically what this is saying is whenever this local script tries to communicate, then it'll do whatever is inside of this function right here. And what we want is we want this stuff right here to be over here. And now we need to get the humanoid root part. Okay. And now instead of all of that happening over here on the client side, we're basically going to put it into the script. So we're basically going to tell the script to do that stuff that we just told it to do. And that's what this does right here. So this right here, fire server, this thing, whenever a local script runs this line of code, the server is going to run all of this. So this stuff is us adding that VectorForce stuff into the humanoid root part. And this local script is basically telling Roblox, okay, I want you to add all of this VectorForce stuff into the humanoid root part of the player that called it. So we're basically, instead of having the local script do this stuff, we're going to have the server do this stuff. And also we want to make that player jump. So we're going to go character.humanoid.jump equals true. So now the character is going to jump, and then we're going to apply the force. And now let's try it. And there you go. So you press X and the character automatically jumps. Bam. And you're dashing. So you press X, bam, X, bam, X, bam. All right, so let me just try to explain this one more time because I know this got kind of confusing. All right, so a local script, which is this thing right here. This thing runs on every player's computer. And this thing right here, this is a server script. This thing runs on, basically, think of like a really, really powerful computer inside of Roblox headquarters. That's where this thing is running. But this thing right here, it's running on the player. So like whenever I load this game, Roblox is going to make this thing run on my computer. And that's how we're able to use this stuff like user input service. Because if it's running on my computer, then Roblox can detect whenever I press X. So that's why we're putting it all in a local script. And also more information about this after I make the long video about remote events, remote functions. Just stay tuned for that, okay? This is just a really, really small explanation. But anyway, so that's what that does. And then this script right here, this stuff is running on Roblox's server. So this is running on a really, really expensive computer inside of Roblox headquarters, probably very far away from all of us, right? And what we want to do is we want to communicate with the computer, or with the script that's running on your computer. This script that's running on your computer has to communicate with the script that's running on Roblox's really powerful servers. And the way you do that is by using this guy right here, this little lightning, this little lightning bolt right here. We call this thing a remote event. And basically how this works is we have one of these. So this is on server event. This thing basically means whenever a player's computer wants to communicate with Roblox's server, that's what this is saying, then this player right here is the player whose computer is trying to make that communication. So what that means is if I'm trying to communicate with the server, then this player is me. If a noob is trying to communicate with the server, then this player is that noob. So this is whoever is trying to communicate with Roblox's server. And then right here, this is a local script. And this line of code right here basically says, okay, server, let me communicate with you. So this is saying, let me fire that communication. So this right here is saying, I want to communicate with your servers on Roblox. So this is my computer wants to communicate with Roblox's really, really powerful computers. And then soon as this line gets called, so this is right after the player presses X, soon as this line gets called, Roblox goes over here and runs this on Roblox's computers. So this right here is running on the server. And this thing right here is all of that force stuff and all of that humanoid jump stuff. So this is the stuff that makes your humanoid jump and applies that force pushing you. All right, so that was basically a crash course. And like I said, there will be a more lengthy video on client and server communication for you later. But here we go. So here's our dash, which is pretty cool. But now let's make it a little bit better. So we're going to add some sort of visuals. All right, let's add some cool visuals. We're going to start with this one right here. I just found this by searching dash effect. And then I think I clicked on this one right here, or this one. It looks the same. Let's see. Yeah, it was basically this one, but I got rid of the lines to make it a little bit more simple for us. So basically, you're going to have your dash effect, and to find it, just look up dash effect in the toolbox, and these are the ones that I clicked on. All right, so here is our dash effect, and what we need to do is we need to basically make it so that this thing pops up as soon as we dash. We're going to start with that, and then we're going to make it a little bit better. So first, this thing just needs to show up when we dash. Let's just start with that. So the first thing I'm going to do is I'm going to take this thing out of the model, and I'm going to delete the model. And then I'm going to take this thing, I'm going to call it wind. And then it has a weld inside. I'm going to destroy it. I'm going to throw this into effect. So this is going to be the wind effect. I'm just going to call it wind effect. So now instead of effects, you should have your wind effect and set anchor to true and can't collide to false. Anchor to true, basically this thing will make it so that it doesn't fall, and can't collide false basically makes it so that you can go through this thing right here, so that your character will be able to go through it without like bouncing off of this ring thing. All right, so take this, put it inside of effects, and let's get started. So I'm actually going to put this entire effect on the server because I feel that I've already confused you guys a lot with this remote event kind of stuff. So we're just going to throw everything on the server for this tutorial. So I'm going to take this wind effect. So the first thing we need to do is we need to take this wind effect, we need to clone it, so duplicate it, and then put it inside of workspace. That's the first thing that we have to do. So remember that this is running soon as someone presses X. This is going to run. So we're going to take that effect. So we're going to say local wind effect equals. All right, so this wind effect is replicated storage.effects.wind effect. So basically this thing is referring to this thing right here. But what we want to do is we want to clone it. So we're going to say local wind effect cloned equals wind effect clone. And then we're going to set the parent to workspace. So we're just going to take this step by step. This is the wind effect. This line right here clones that wind effect. So what it does is it duplicates it. And then that new one that we cloned, it's going to set the parent to workspace. So that's what that's doing. It's duplicating it and then putting it inside of workspace. Let me just show you that that much works. I'll press X, and as you can see, it worked. It put it inside of workspace. Now the issue here is that this thing shouldn't be over here. It should be on my character, right? And the way we're going to do this is we're going to set the C frame to the character C frame. So C frame right here, this thing basically means position with orientation. So this thing is moving, this line of code right here is moving the wind effect to the humanoid root part. So it's basically, so this is my humanoid root part. So inside of my character, here's the humanoid root part. It's an invisible brick. You can't really see it, but maybe now you can see it. This right here, this gray thing, it's called a humanoid root part. This thing is an invisible brick inside of your character. So here, as you can see, it's inside there. You just can't really see it. And what we're going to do with this line right here is we're basically telling Roblox, take this wind effect that you cloned and then position it into wherever the humanoid root part is positioned. And also make it face in the same direction that the humanoid root part is facing. So it's going to position it and rotate it just like that. So as you can see, it did it. However, we don't really want it like this. I mean, maybe we do. Maybe what we can do is we can make it so that it appears to show a jump, and then we have another one that shows the dash. So maybe boom, it jumps, and then another one shows it dashing. So let's just do that. How about that? So we have it showing. Let me destroy it really quickly to show you. So this line makes it show, and now we're going to destroy it because after our dash is done, we don't want to see it anymore. And I'm actually going to rename this to wind effect jump. I'm going to just rename everything. So now, boom, and then it gets destroyed. Once again, boom, destroyed. Boom, destroyed. Hopefully you guys can understand what that's doing. And this thing right here is destroying it. And now what we want to do is we want to give this some sort of effect. All right, so now we want to basically animate that effect so that it looks a little bit cooler and it's not just instantly appearing and then disappearing like that. We want it to have some sort of effect. So I guess there's a few ways to achieve this. One is using tween service, another one's using linear interpolation. I think what we're going to do for now is why don't we just use linear interpolation, just because I kind of like that. So let's do this. Let me actually show you a little bit of what we're going to do first. So here's our wind effect, right? And let me just show you it in the exact orientation that you see it. So here's your wind effect. So what our script is currently doing is it's showing it and then it's destroying it. But we want to be a little bit better with that. So instead of showing it and disappearing it right away, we're going to show it and then we're going to have the transparency go from 0.25 all the way to 1. Okay? So instead of just instantly disappearing like that, we want it to slowly fade out like that. So we're going to start with that. And the way we're going to do this is we're going to use a technique called linear interpolation. I'm actually going to have the transparency start at 0. So we're basically going to take this thing's transparency and make it go all the way to 1. Now, let's actually code that up. All right, so I've coded it up right here, and here's the entire thing. So we're using linear interpolation for this. Sure, you could use tween service, but I like to use linear interpolation for this. And the way this works is basically, remember that what we're trying to do is we're trying to get this thing's transparency, which is right now set to 0. We want it to go slowly all the way to 1. And I do have a video on this called, it's on my channel. It's called Understand VFX Scripting with this video. If you're confused about this, please check that out. So what we're trying to do is we're trying to get this transparency to go from 0 all the way to 1. And one way to do this is by setting the transparency to 0 and then setting it to 0.1 and then setting it to 0.2 and then setting it to 0.3 and then setting it to 0.4 and then setting it to 0.5. And as you can see, it's slowly fading out it's slowly fading out the more that this becomes increased. So 0.9 and then eventually 1 and then it's faded out. This whole process is called linear interpolation. This is a simplified version. And what we're doing here is, let me just start with 10, I guess. So this right here, this is called a for loop. And what it's doing is it's saying, okay, 10 times set the transparency of this wind effect, which is this thing right here, set its transparency to I divided by 10. So what that means is I first starts at 1. So this is basically counting from 1 to 10. So think about this as count from 1 to 10. And I is basically the counter. So I starts at 1, and then I becomes 2, and then I becomes 3, and it becomes all the way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this thing right here is saying set the transparency to whatever I is divided by 10. So when I is 1, I divided by 10 is the same thing as 1 divided by 10, which is the same thing as 0.1. When I is equal to 2, I divided by 10 is the same thing as 2 divided by 10, which is 0.2. And then I is 3. And then I divided by 10 is the same thing as 3 divided by 10, which is 0.3. And then it goes on and on and on all the way until I is 10. And then I divided by 10 is the same thing as 10 divided by 10, which is 1. And that is how we achieve this whole thing where the transparency is 0.1 and then the transparency is 0.2 and so on all the way until 1. So that is called linear interpolation. If this is really interesting to you, I have an article on this and I will link it down below in the description. So this whole thing is called linear interpolation. You can use tween service, but I'm using linear interpolation just so I can teach it to you. And that's how that works. And then this task.wait is basically saying wait really, really small. So let me just do this. So this is saying wait 0.01 seconds and then increment I. So I becomes 1, this becomes 0.1, and then it waits 0.01 seconds, and then I becomes 2, this becomes 0.2, and then waits another 0.01 seconds, then I becomes 3, this becomes 0.3. So that's how that works all the way up to 10, and that's going to give us that cool fading effect. Whoops. Gotta get this thing back there. And now let's take a look. Okay, that was a little bit too fast. Let me set the transparency to 0 so you can see it. So boom, as you can see, it slowly faded out. Look at that. See that? Slow fade out. And I'm actually going to make this a little bit better by changing this to 100 and changing this to 100. So instead of going 0.1, 0.2, 0.3, now we're going to go 0.01, 0.02, 0.03, all the way. And this is going to make it really, really smooth. Okay, it was smooth, but it took a little bit too long. So you know what? I think we'll just stick with 20. All right, bam. There, I think I like that. Now, what we want to do is we want to make this thing look even better. So what we're going to do is we're going to make that thing appear, and then we're going to make it rotate a little bit as it fades out. So here's the wind effect. We want this thing to rotate now. So we're going to make this thing go like wee. We're going to go wee like that, and it's going to fade out at the same time. It's going to be really cool. Keep watching. This is going to be awesome. So I'm going to put this back here. Now, this right here, this is controlling the transparency. Let's do wind effect jump dot cframe equals cframe times cframe dot angles. Let's just do this. So let me just try this, see if it works, and then I'll explain it to you. Okay, great. It does work. So this right here, basically what this is saying. So C-frame is something that has both position and orientation. That means C-frame controls where this thing is located and where it's rotating. So like whatever direction it's rotating and whatever location it's in, that's both encoded inside of the C-frame thing. And what we're doing here is we're saying set the C-frame of the thing to whatever the C-frame used to be times cframe.angle0 math.rad50. So this is where it gets a little bit confusing. This right here is saying set the C-frame of this wind effect thing to whatever it used to be, multiplied by 5. Think about this like 5 degrees. Sure, it's 5 radians, but think about it like 5 degrees times 5 degrees. So if you think about, okay, so let's take this over here. You see this green thing right here? Imagine me doing this to it. That's 5 degrees right there. That is what this thing is doing. Sure, it's using radians, but radians is a little bit complicated to explain right now. So just think about it like that. So it's literally 20 times. It's going this, 5, and then do it again. 5, and then do it again. 5, and it's doing this 20 times. And while it's doing this at the same time, it's doing the whole transparency thing that we did that made it fade out. So it's literally rotating and fading out at the same time. It's actually really, really cool. Here's what it looks like. Okay, a little bit hard to see. See that rotation right there? Here, let me... Okay, that was kind of hard to see. Right there, see that rotation? Pretty cool, pretty cool. Now, why don't we, let's see, how can we make this even better? All right, one thing that I think we can do is we can make this a little bit faster. So let's just make this like 15. Let's see what this does. Okay, there, that's okay for me. That's all right with me. All right, so there's a jump, and I think what we're gonna do, that's pretty cool. It's like a super jump. All right, so we have our little super jump thing right there. And one thing we can do to improve this is in the middle of our jump, so like right here, we can introduce another one of these dashing things where it's going to look like this. It's going to look like this right here. And then boom. Okay, so it's going to jump, and then it's going to show another one, and then it's going to continue the dash. That's what we're going to do. So to do that, we just have to do that whole thing with our wind effect again. All right, so we have our wind effect jump. Now let's actually do our wind effect dash. And what I'm going to do is I'm going to do a task.weight 0.08. And then over here, I'm going to do a task.weight 18 or 17. Okay. I'm going to call this wind effect dash. All right, so I've gotten this to a point where it looks a little bit better. So here's what it looks like. So you dash, and now you can see there's that one thing for when you jump, that one wind, and then there's another one that kind of pushes you. as you can see. Now here's how I did that extra wind. We used I used this variable right here, wind effect dash. So we have wind effect jump. Now we have wind effect dash. And remember, this one right here is this one right here. So it's this wind effect, but instead it's facing this way, like that. And what we're doing is we're basically doing the same thing where we're cloning the wind effect, putting it into workspace, but instead now, instead of just putting it into the humanoid root part C frame, we are rotating it by 90 degrees in radians, which is math.pi divided by 2, but we're not going to get too technical with that. Basically what that's doing is it's cloning this thing, putting it into workspace, and then it's positioning it to wherever your humanoid root part is. Remember, that's the invisible brick inside of your character, and then it's rotating it by 90 degrees, which is basically it's taking this thing and it's doing this to it. Boom. And that is what this line right here does. Sets the C frame to wherever your humanoid root part is looking, and then multiplying that by 90 degrees. And yes, you can do this if you wanted to, but yeah, you can do that. This is just math.pi is 100 degrees, but in radians. And then we divide that by 2, which is 90 degrees, but in radians. But we're not going to talk in radians in this video. And I say that as typing math.rad. We're just going to try to keep this thing simple and not get too mathematical. So we're just saying 90 degrees, okay? All right, so that is going to give you, bam. I think that's all right. Sure, it's not, it's not the best, but I think this is pretty good for a YouTube video. All right, so sometimes dashes also have these lines right here. So if you want to make these lines here, let's just make these lines from scratch. So to make these lines, you can just add a part, set the brick color to white, set the material to neon. This is going to make it glow. And then you can just scale it so that it's super thin. Maybe something like this. Boom. So these are like your dash lines. And maybe I'll make this a little bit. Maybe, is that too small? Okay, there. So I'm going to call this dash line. And then maybe I'll have maybe I'll have some lines that are a little bit longer. So I'll Control D to duplicate this. And then I'll make one smaller. Control D. Maybe I'll move this one right here. And I'm literally just messing around with this dash, trying to get it to a way that looks kind of cool. Kind of cool. All right, so these are like my dash lines. And I'm just going to duplicate again, make a couple more. All right, so basically, I want these lines to appear when my character dashes. And the way I'm going to do this is I'm going to group these. So Control G. I'm going to call this dash lines. So inside of my model called dash lines, I have all of these parts called dash line. And I'm going to take this and move it into effects. So now we have a model called dash lines inside of the folder called effects. All right, so remember how we did the wind effects? We're basically going to do something similar for dash lines. So we're going to say local dash line equals, and we need to have a variable that represents the dash lines folder. So now this thing is referring to this thing right here. And then we're going to call this dash lines clone. All right, so now we've cloned the dash line. So we've basically done that to it. And then we've set the parent to workspace. So we've done that. And what we need to do is we need to get all of these parts. We need to get all of these parts into a position. So basically what we need to do is we need to take this and we need to move it so that it's facing the same direction as your character and that it's located in the same direction as your character. So the way we have to do that is we have to use something called pivot. So because dash lines clone is a model and it's not something like a mesh part, So as you can see, a mesh part has something called C-frame that you can set. But a model, however, this thing does not have a C-frame that you can set. It does, however, have something called a world pivot, and that's what we're going to use. And the way to set this world pivot is by using pivot 2. And the reason that we have to do this is because this thing is a model. So this thing is a group of parts, while this thing right here is just one part. This whole thing is one part. But this thing is a lot of parts. So as you can see, there's a whole bunch of parts inside of this model. And that's why we have to use something called pivot 2. Alright, so now we're going to make these lines basically become located. We're going to pivot them so that they are at the exact position of your humanoid root part. So we can just do something like this. And also take all of your dash lines and then make sure that they're anchored and that their can collide is false. This thing will make sure that they don't fall down, and this thing will make sure that your character can go through them without any issues. And lastly, I'm going to destroy the dash clones. After I'm done, let's see what this looks like. Okay, that's a lot of effects. Okay, so the first thing I immediately notice is that they're kind of facing side to side, as you can see right there. We want these to be facing in the position of your character. So one way you can do this is we can do something like we did here, where we basically multiplied it by some degrees. And that's what we're going to do right here. So basically, your dash lines are facing this way. So like maybe if your character is facing this way, your dash lines are facing this way. We want our dash lines to be facing this way, which is the same direction as our character. And one way you can do this is by using pivot 2, which is going to, one way you can do this is by using C-frame.angles. And what we're doing is we're basically taking it and rotating it 90 degrees, just like this, in radians, but in this video we're not covering radians. So let's see what this does. Boom, okay. So basically what that means is maybe this was in the wrong location, so maybe this should be over here. Okay, as you can see, now the lines are actually facing us. You see that right there? Look at those lines. Bam. Now, we want those lines to not appear over there. We want these lines to appear in a slightly delayed fashion. So right now they appear instantly as soon as you jump, but I want them to appear when you're in the air. So I'm going to put them over here and let's see what this does. Okay, so as you can see, now they're appearing in the air right there. You see that right there? Right there. That's pretty cool. However, I want these to appear a little bit later. So I'm going to use something called task.delay. Alright, so basically, this is using something called multi-threading, which is, again, a little bit too advanced for this video, I guess. But basically, just think about this like 5 seconds later, do the dash line stuff, wait 1 second, and then destroy them. And this is all happening at the same time as everything else, which is what makes it a little bit confusing. So everything is happening all at once. 5 seconds later, we're showing the dash, and we're destroying it 1 second after that. So, boom, 5 seconds later, show. Oh, you see that? Oh, I said 5. I meant 0.5. Yep. So that is a little bit too slow. So as you can see, it showed the dash lines after our dash had ended, which doesn't make any sense. So why don't we do a 0.1 instead? Boom, boom, right there. See that? Now it's over there. Now I feel like maybe this should be a 0.2 and maybe this should be a 0.4. So it destroys a little bit faster, 0.3. So I'm just tweaking the numbers until I like it. All right, you see that right there? It's pretty cool. Okay, it's not bad. That's not bad. Let's try 0.3. Okay, maybe I want it 0.1. I think I'm okay with that. So bam, and you have all three effects happening just like that, which is pretty cool. So you're welcome to tweak this any way you want, just to get whatever effect you want. I'm just having a little bit of fun with this. Boom, bam. It's pretty cool. It's pretty cool. Actually like it. It's pretty cool. Bam. Alright, so that's pretty cool, but I want to add a sound effect. Okay, so let's add a sound effect. So I'm going to go into audio. Okay, dash sound effect. Nice. Okay. Okay. So I'll just use this one. And what we're going to do is we basically want Roblox to play this. And let's just put this inside of the wind effect. Call it dash. And I want to set the volume to 1. So basically all we have to do now is inside of the wind effect dash, we just have to play the sound. So wind effect dash, which is this thing right here, dot dash, which is the sound right here, and then we're playing it. Whoops. And then we're playing it. So that's going to play the dashing sound. Okay. Let's make that a little bit louder. So 3. And as you can see, as I move my camera closer to the actual effect, you can hear the sound a little bit louder. Cool. Let me try this with a different sound effect. Okay. Let's try this one. So I'm going to call this dash old. I'll call this dash. Set the volume to 3. Whoops, that's playback speed. Wow, I am really tired. Set the volume to 3. Okay, good. And now because it's always gonna play dash, it's gonna play this one. Pretty cool, pretty cool. Maybe what we should do is we should make the dash play right on the jump. So this is going to play it immediately. So there. That's a little bit better. Pretty cool, right? Pretty cool. We've got our effects. And now if I'm too lazy, I can just dash. If I'm too lazy to go to the spawn location, let's see how many dashes this takes. Ready? 1, 2, 3. 1, 2, 3. Oh, I missed it. Oh no, I missed it. Oh no, I missed it. Okay, so by now you guys have learned a lot from this video, but there's still some more stuff we can do to make this a little bit better. The first thing is we need to prevent people from spamming. So that's the next thing that we have to do. Alright, so I've basically changed up the code a little bit to make the dash look better. I've used something called multi-threading. If you're interested in that, please let me know in the comments down below, and I'll make a separate video on that. And basically, here's what a dash looks like right now. So here we go. Boom. It looks a lot better in my opinion. It looks a lot cleaner, as you can see. So boom. Pretty cool, huh? I actually really like this effect. So as you can see now, it's a whole lot better. There's like trails and yeah. So yeah, if you want to copy my code, you're free to do that. Everything is right here. You can pause the video and just follow along. Alright, so now we have to add something called debouncing. And what that basically is, so right now if I spam X, it's going to let me dash like that. And that's not good, right? So we have to add something called a debounce, which is basically like an anti-spam mechanism that basically makes it so that players can't spam X and just dash all the way through the game's map, as I just did. So that's what we're going to do. We're going to add a debounce. One way we can do that is we can do something like this. So we can say local. So what we're going to do is we're basically going to keep a list of the last time every player has dashed. And that's what this is going to be right here. This is going to be a list. And what this is going to hold is basically the last time that any player has dashed. Alright, so before we can get into this whole thing, let's actually understand how tick works. So I'm going to be using something called tick. So if you type print tick, it's like this, print tick, and then you have the 2 parentheses because tick is a function. If you print this, as you can see, it prints out some number. So this is some number, right? It's let's see, it looks like this is 1 billion. So it prints out this 1.7 billion number. And if I press it again, it print out a different number. So every single time I print this thing out, it's printing out a different number, just like that. If I just spam this, as you can see, it's just printing a whole bunch of numbers. But if you look closely, you can see that this last number right here is actually increasing at a steady interval. And this is actually increasing every single second. So basically what tick does is it gives us the amount of time that has passed since some point in time. So basically 1.7 billion seconds have passed since some point in time. And if I press enter here, now it's saying 741,510,460 seconds have passed since some point in time, right? And if I do it again, the number is different. So if you make an observation here, you can see that if we print tick and then we wait like 2 seconds and we print tick again, look at what happened. It showed us that 2 seconds have passed in between each tick. So let's try it again. Print 0 Mississippi, 1 Mississippi, and as you can see, if you take this number and you subtract it from this number, or if you take this number and you subtract it from this number, so if you do this 94 minus this 92, you'll end up getting something that's close to about 2 seconds. And that's how we're going to figure out the time that has elapsed since the last time someone has dashed. So basically what we want to do is, let's say that this 92 number represents this tick right here. So this is basically saying this giant number, 92 seconds have elapsed since some time. And this number is saying blah, 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 94 seconds have elapsed. And we can actually look at this like this. So at this point in time, 92 seconds have elapsed. And in this point in time, 94 seconds have elapsed. And what we're going to do is we're going to say, okay, so if I first use the dash, if I first press X on my keyboard right here when 92 seconds have elapsed, then if I try to use it again here before this 94 seconds have elapsed, then we reject it. And what that means is if I try to spam X really, really fast, so like I spammed it here, like I pressed it here, and then I pressed it here, and then I pressed it here, I pressed it here, we don't want anything to happen because players are spamming. However, if I press X over here, then that's okay because 2 seconds have basically elapsed. So the way that we do this is we use I call this a tick difference. So we do tick minus the last time you used it. So if let's say that you use it right here. So let's say that the first time that you use this dash thing is over here, and then the next time you use it is over here, then that's okay because 2 seconds have elapsed since you've last used it, right? However, if you try to spam it, so if you try to do this thing where you're like spamming X, 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 then we don't want anything to happen because you're spamming it and 2 seconds have not elapsed yet. So that's kind of how you want to think about this. And we're basically keeping all of that information in this table called the last time each player has dashed. And yes, this can be very complicated to understand. This is like intermediate level. So if this doesn't make sense, it's okay. You just have to watch this a little bit. You just have to kind of repeat this. If this doesn't make sense, don't worry too hard about it. Just try to follow along. So this thing right here, we're basically going to store all of these times. So let's say that, let's say that we have player 1 and this player used the dashing thing. We'll use orange. This player pressed X right here. And then this player is pressing X again right here. Well, then we don't want this to do anything because 2 seconds haven't elapsed yet. Maybe this is like 92.2. And if you do 92.2 minus 92, you get 0.2. That means 0.2 seconds have elapsed since the first time this player pressed X and the second time this player pressed X. And that is less than 2. We basically want the player to only be able to dash every 2 seconds. And yes, this is kind of math heavy, but that's basically what we're trying to do. And if the player presses X over here, maybe this is 93. Then if you do 93 minus 92, this is equal to 1. That means that the player has pressed X to dash 2 times within 1 second. And we don't want that to work. So that is the intuition behind what we're doing over here. behind what we're about to do over here. And this thing right here is a table. And this thing is just going to keep track of every player. So maybe you have player 1. And this thing is keeping track of the last time every single player in our game has dashed. So player 1, maybe the last time they pressed X was at 92, which is over here. And what we're going to do is maybe they try to press dash again, or maybe they try to press X again, and maybe that X is at 93. So like, this is when they last dashed. This is when they're trying to dash again. Then once again, all we're going to do is we're going to say, okay, 93 minus 92, that's equal to 1. And that is less than 2. That means that 2 seconds have not elapsed since the last time, since the difference in the times that they've dashed. So let me actually just start coding this. Maybe it'll make a little bit more sense. So we're going to say the last time that this player has dashed is equal to tick. So the last time that this player, the player that's pressing X, has dashed is equal to tick, which is basically these numbers right here. And what we're going to do now is we're going to check the difference in the last time they've dashed and the current time they've dashed. And we're going to check to make sure that it's less than 2. So that means that the time that has elapsed between you pressing X and then you pressing X again has to be within has to be greater than 2 seconds for it to work. So, all right, so basically we've basically set it. So we've basically made it so that I've pressed X and the server is going to keep track that I have pressed X. And that's what this is doing right here. And now what we're going to do is we're going to make sure that... All right, so here's how we're going to handle this. All right, so here's how I'm handling this. So once again, I'm just going to run you through this because this is really, really complicated for beginners. We have a variable called the last time every player has dashed. This is going to hold every single player in the last time that they used the dash. So for example, if I use the dash when the time was 92, then it's going to hold this. It's going to say player 1 has used it when it was 92 seconds. Then we're basically going to check if the current time minus the last time that that player has dashed is within 2 seconds. What that means is I've dashed at 92 and then maybe I spammed X over here. Now it's 92.2. Then you do your 92.2 minus your 92 and that's equal to 0.2. Guess what? That's less than 2. And what this basically means is that I spammed X 2 times within 2 seconds, which is bad because that means you're trying to spam. And that is what this is doing. This is saying that this player tried to spam X within 2 seconds, and that is classified as a spam. And then we have this return, which basically means do nothing. So if you try to, this basically just means if you try to spam X within 2 seconds, then don't do anything. And that's going to fix our issue. So if I spam X, watch, ready? Watch this output. I'm going to spam. I'm spamming X. Within 2 seconds, nothing is happening. But the moment that it's been 2 seconds since the last time I've spammed X, then we're allowed to dash again. And that will fix the issues with the debounce. So I'm just spamming X, and as you can see, boom, 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 boom. Everything is working perfectly. All right, so now I'm going to help you do a mini version of the agility system. So here's what we're going to do. We're going to say that every player has an agility, which is going to be a variable. And we're going to say that their agility is like, let's say it's 100, sure. Actually, no, let's say it's 2. So every player has an agility of 2. You know what this means? We're going to say that 2 is a low number. That means that if your agility is 2, then your dash is barely going to dash. Like your dash barely will do anything. But if your agility is like 100, then dash a far distance. So basically, the higher that your agility is, the farther you're going to dash. And that's what we're going to do here. So all we have to do is remember that we're removing our vector force after 0.25 seconds. What if we, instead of removing it 0.25 seconds, we only remove it, or we remove it proportional to this agility? And what that means is, if my agility is really, really high, then maybe this is like 1. But if my agility is really, really low, then maybe this is like 0.05. All right, so sometimes you do need to bust out Desmos, which, you know, some people are going to look at this and they're going to have nightmares. I hope you don't. I'm going to try to make this really, really easy and really, really simple. So let's say that over here, you have an agility of 2. And let's say that we're going to do a task.wait on the agility. So what that means is it's going to wait 2 seconds because my agility is set to 2 and I'm going to do a task.wait on that agility. So basically task.wait for 2 seconds and then destroy the vector force. And that's exactly what we're doing here. So if the x-axis is your agility, so maybe your agility is 2, right? So if your agility is set to 2, then the script is basically saying wait for that 2. So it's going to wait 2 seconds. So if your agility is 2, it's going to wait 2 seconds. And let me show you why that's bad. So if your agility is 2, here's what happens. That is way too far for someone that has an agility of 2, right? That's really, really bad. So what we're going to do is we're going to add a factor into this x variable. So remember that x is going to be your agility, y is going to be the number of seconds that you wait. Maybe we'll make that factor like 0.01. So now, if your agility is 2, it's going to wait, let's see, if your agility is 2, okay, so if your agility is 2, it's going to wait 0.02 seconds. Okay, what if your agility is like 100? Then it's going to wait 1 second. Well, let's see how that goes. So basically what we have here is 0.01 times x, and x is our agility. So I'm going to say 0.01 times the agility. And now, press x. Whoa! I have an agility of 2 and it barely did anything. So that's awesome. However, that wasn't much of a dash, was it? So that means that our formula is kind of wacky. So why don't we change the slope? Why don't we try 0.05? So now, if I have an agility of 2, it's actually going to destroy this vector force after 0.1 seconds. So I'm going to try that. So let's try 0.05. That worked pretty well, actually. If I have an agility of 2, I shouldn't be dashing that far. So yeah, there we go. That worked out pretty well. And let me actually set this agility to like 100. Let's see what happens if our agility is 100 according to this formula right here. This is a linear formula. Boom. Look at that. Oh, that's way too far. Whoa! For someone that has an agility of 100, we don't want them to go that far, right? So we have to make some adjustments to our formula. Or what we can do is we can say that the maximum agility in our game is like 50. So if the agility is 50, okay, that's still way too far for a dash. So that means that something is wrong with our formula. So let's actually manipulate this a little bit. All right, so I've basically complicated this, I basically plotted this function right here, 0.1 times the natural logarithm of x. You don't have to worry too hard about this. This is just a mathematical formula that works really well for this duration until deletion thing. However, if you do want to know more about this, just leave a comment in the description. I'll probably write an article about this on my blog. This is just a formula that works really, really well for when your numbers on the x-axis are getting higher and you don't want the numbers on the y-axis to get too high. So the way you can code this is by using this right here. So this is the duration until your vector force gets deleted. So if this duration number is really, really high, then your character will go faster because the force is being applied for a longer time. And you can just code this out. This will work for your game. So all you have to worry about is if I set this agility to 2, it works well. And if I set this agility to like 50, then it doesn't shoot me off the map like it did before. So it's basically a formula that works really, really well for this kind of scenario. Now, of course, for your own game, this agility is going to be some sort of value that depends on the player. So maybe you have like a leaderboard right here where it says agility, and then maybe I have an agility of 2, maybe another person has an agility of 50. And that is all stuff that you're welcome to adapt this code onto. But yeah, in this video, you have learned all about making an anime dashing system, which looks really, really cool. And it has debounce, and it has a small version of an agility system built into it. So if you like this video, make sure to check out my blog. I have tons of free articles on Roblox scripting, computer science, and a whole bunch of stuff. So if you look over here, Roblox scripting tutorials, there's all of this stuff with more to come. I'm writing more and more and more for you to learn. So if that sounds interesting to you, to make sure you check it out. If you skipped around and you just want the code and everything in this game, I will also leave a link for that. See you in the next video.